Okay, our third and final problem for tonight, 2016, number 6, no calc. You're going to see the theme. We're either going to have graphs or grids, and we're going to solve our answers out from there, and they're going to be picky about having us use rules for derivatives or integrals. Remember, we know that the quotient rule is u prime v minus uv prime over v squared. They're going to have us manipulate numbers to figure out which ones actually fit into those spots. So let's take a look at the first part of the problem. I have a table of values. The functions are continuous in the second derivative, so they'll always end up working. The table above gives the values of the functions and the derivatives at the selected values. They're saying that k of x equals f of g of x. They want me to find the tangent line. I'm going to actually find the tangent line to the graph of k at x equals 3. So formula for a tangent line, L equals, f prime of c times x minus c plus f of c. Okay, now here's where the stuff gets a little tricky. We know what the c is. The c is 3. So already I could fill in the 3 there, but we have to translate what we're looking to graph compared to the information I have down there. So I know that this is really going to be for the graph of k. So instead of f in here, I'm going to rewrite it using k, and I'll fill the 3 in. L equals k prime of 3, x minus 3, and k of 3. Okay, so I'm going to have to use this information to find the missing pieces. I'm going to do the last part first, just because I think that's easiest part for me. How am I going to find k of 3? Well, k is equal to f of g of x, so I have to find f of g of 3. So g of 3 is 6, and then f of 6 is 4. So f of g of 3 is 4. So I've got that part on here. The x minus 3 goes here. But now I need to take the derivative of k to solve that out. Well, let's see what k is equal to. A lot of work on this, I know. This part is the harder part of the batch. I've got to take the derivative of that statement right there, which looks like a chain rule. So it's f prime of g of x times the derivative of the inside, which is g prime of x. And now I'm going to substitute in 3. So g prime of 3 is 2. G of 3 is 6, so this is now 6. And f prime of 6 is 5. So 5 times 2 is 10. So my equation is L equals 10. X minus 3 plus 4. Whew, a lot of steps to get there. Let's take a look at B. Okay, we're on to part B. They give me my function h is equal to that, and they want me to find h prime of 1. Well, I see a quotient rule, which is u prime v minus uv prime over v squared. I'm going to translate that to the terms I have here. So it's going to be g prime of x times f of x minus g of x times f prime of x all over f of x, close parentheses, squared. So I'm solving this at 1. So I need g prime of 1, which is 8. I need f of 1, which is, almost circled the wrong one, f of 1, which is negative 6. I need g of 1, which is 2. I need f prime of 1, which is 3. All of that over f of 1 squared, so it'd be negative 6 squared, which is 36 on the bottom. When I write this out, I'm not going to simplify it. 8 times negative 6 minus 2 times 3 over 36. You can leave it just like that. You can simplify it down if you want to, but I'm not going to do that here. Okay, if you really want an answer, it's negative 54 over 36. Okay, last part. Last part looks like it could be complicated, but it shouldn't be too bad. I want to treat this integral like I do any other integral. I'm going to integrate from 1 to 3, f double prime of 2x dx. Now, although there's no numbers there, don't freak out. I'm going to follow the normal steps I do. First, I need the derivative of the inside sitting in that dx. In order to integrate, the derivative of the inside has to be sitting there. The derivative of the inside of 2x is going to be 2. So I need to place a 2 in here, counteract it with a 1/2 out front. Okay, do I have the derivative of the inside set to go? If it does, when I integrate, I'm just integrating the outside function. So the integral of f double prime would be 1 less, would be the integral of that would be f prime. So that 1/2 f prime of 2x from 1 to 3. As a quick check, I could take this original statement right here, which is 1/2 f prime of 2x. I'll take its derivative to show you that I get back the right answer. What I'm doing right now you don't have to do. I'll mark that in orange. This is not part of the problem. The derivative of 1/2 f prime of 2x would be 1/2. Derivative of the outside would be f double prime of 2x times the derivative of the inside, which is 2. These would cancel, and I get back what I started out with. Once again, not need to be done, just a little extra explanation to help out. Oh, a lot of little things I wrote there, almost. Okay, so now that I've integrated, it's going to be equal to 1/2 f prime of 2 times 3, which is 6, minus 1/2 f prime 2 times 1, which is 2. So f prime of 6 is 5. One-half f prime of 2 is -2. You could leave it just like that. It'd be just fine, or you could solve it out if you wanted to. I'm going to leave it just like that. Okay, there's our 3 videos. Good luck tonight.